Alright everyone, welcome to our lesson. So during this video we're going to talk about lesson 4.1. During lesson 4.1 we have three parts to talk about. The first part is going to be one-to-one functions, and secondly we will talk about inverse, and lastly we will talk about equation of inverses. So let's get started with the first one. There's like a long definition here, but I want you to stop at this point and read it. But to be one-to-one function, that's my criteria. In one-to-one function, each x value corresponds to one y value. And to make it easier, I go with this way. So like in order to be one-to-one function, y value, which is like second order pair outcome, shouldn't repeat. If we see that repeating, that function won't be one-to-one function. Let's have a look at those examples. So let's have a look at the table first. As you see here, let's look at my y values, second values, right? Like 3, 5, 0, 4. So it looks fine. So this function should be 1-to-1 function, right? We are good. But if you look at the second example, look at this one, 4 and 4. As you see, it's repeating. So this gx function, it's not 1-to-1 function. Alright guys, have a look at this example now. Like 1 goes 5, 3 goes 6, 2 goes 7, 4 goes 8. Like all is fine, no repeating values there. So it's going to be 1-to-1 function. But if we look at this one, like 5, 9, 4, 8, 1, 6 is fine. But look at this one, 2 goes 7 and 3 goes 7. Like 7 is repeating there. But that's why this example is going to be not one-to-one function. So y value shouldn't repeat, like no repeating. Alright, that's how we decide if we have table, if we have map diagram. What about like if we have a equation? How do we decide is one-to-one or not? There's a tricky way. I will show you that one later on. But first, let me show you how it works. Okay. So as I mentioned earlier, y shouldn't repeat, right? Shouldn't repeat. Like as you see, those are my y values, right? So like whatever we plug in here, I will get something else, right? Let's say I plug in x equals 0. So in that case, if you put there 0, outcome should be what? Negative 4 times 0 plus 12. So it's going to be just 12. So my outcome is 12. Let's say if you put there x in 1, so let's plug in there negative 4 times 1 plus 12. So it's going to be 8, right? So like whatever you plug in here, you should be getting like different numbers. 12, 8, and so on. That's why this function is going to be 1-to-1. Okay. For each income, you should be getting different numbers. But on this one, it's not going to happen. Okay, folks, let me show you that. Let's say here, let's plug x2 and let's plug in x negative 2. And let's see what happens. Oh, I don't want to, okay, not that one. Let's plug in there negative 3 and negative 3. Let's see what happens. So it's going to be 25 minus 3 square. It's going to be what? So this is 9, 25 minus 9, square root of 16, which is 4. Have a look at this one. It's going to be 25 minus negative 3 square in square root. Let me go this way so we can see better. So negative 3 square should be 9. So it's going to be 25 minus 9 anyway. Because like negative, like if you square 3 square is 9. Negative 3 square it's 9 too. So it's going to be square root of 16. So it's going to be 4 as well. I want you to see that like we plug in different values, but we got same outcome. So that's why, like, y is repeating, outcome is repeating. So that's why this one is going to be not 1 to 1 function. But especially like tricky is if you have like x squared, if you have x to the 4th power, x to the 6th power, but they are not going to be 1 to 1 basically. Other than that, like most of the time, like 99% of the time, they are going to be 1 to 1 functions. Like I want you like stop the video and have a try those. Okay. Again, you can refer back to this one, but there's like another way to decide are they 1 to 1 or not. Okay, so which is horizontal line test. A function is 1 to 1 if horizontal line intersect the graph of the function at most once. Let's say, let me make up a graph over here. Let's say I got, that's my, okay. Let's say I have such a graph like this. All right, folks. Let's check this function is a 1 to 1 or not. If I have a horizontal line like this, as you see it crosses twice. So let's say this function is fx, so it's going to be not 1 to 1. But let's say if I had something else like this, let's have gx function over here. Let's say it's going to look like this. All right, let's have a vertical line test again. Let's see what happens. My vertical line will cross it once. Even if you go here, it's gonna cross it once as well. So it's going to be 1 to 1. All right. So let's have a look at those examples. So that's my graph, that's my function. Let's determine are they 1 to 1 or not. So if I have a vertical line like this, as you see, this graph is crossed so many times. So it's going to be not 1 to 1, right? But on this example, a little bit different. Like as you see, this horizontal line crosses once. Even if you go here, it will cross it once. It doesn't matter. Like any horizontal line test will cross it once. So it's going to be fine. So it's going to be 1 to 1 function. Very good. Alright guys. So let me show you this. Here we are. I want you make sure you try those everyone. This determine are they 1 to 1 or not. Okay. Before I move on to second part of this lesson, let's say you got those equations, right? You're gonna determine are they 1 to 1 or not. Let's say you're having a hard time to solve this, but tricky way would be just graph and see them. Let's say let's say 18, 4x plus 20. Let's go to Desmos. Let's see what we got there. So it's going to be y equals 4x plus 20. Am I right? Yes. So as you see, there's a linear line. Any horizontal line should be fine. So I can say that, oh, this function should be fine. It's going to be 1 to 1. All right. And let me try this one as well, but I want you to do others. Let's say square root of 36x. Oops. Okay. Y equals square root of 36 minus x square, right? Yep. Oh, here we are. So let me take this over here so we can see better. So let's say if I have a vertical line like this, it's gonna cross my graph twice, not once. So this one should be not 1 to 1, right? Like on this example, as I mentioned, You can go this way, earlier way, or you can just graph and see it. I believe that's the easiest way to see. Alright then, this is part 1 and we are done with this one. Let's move on to second part. So let's say we got two functions that to decide they are inverse of each other or not. That's my criteria, that's my rule. F of g of x should be equal to g of f of x. Alright folks, that's my criteria, that's my rule there. So let's say we got these two functions. G is g the inverse of f function. So let me work on the new page over here. I have enough space. So to be inverse of each other, that's my criteria, right? F of g of x, right, should be same as what? G of f of x. We're gonna do this. Let me calculate this. Let me calculate this. At the end, if we get same thing, yes, g is the inverse of f. We're gonna say, yeah, they are inverse of each other. But if we end up with something else, if we end up with different values, we're gonna say that g is not inverse of f. Let's try this first. So it should be, so f of g of x, right? So this x goes to g first. So I know what gx function is, right? Which is over here. I'm gonna take this, put in here. F of cube root of x plus 1. And after this point, I'm gonna take this value, put in the f function. Let me take this, go to f function. Cube root of x plus 1 to the third power minus 1. Now let's calculate this. So it should be, as you see, cube root and 3 cancel each other. We have left x plus 1 minus 1. So they will cancel out of each other, cancel as well. So we end up with x. Let me keep it here. Let me try this one. Let me see what I got here. So this one should be x goes to first one f, g of f of x. I know what fx is, right? Which is over here. Let me take this and put in here. The g of x to the third power minus 1. That's what I got here. So I can calculate this one. I'm going to take this value, go to g function, plug in here. It should be cube root of x to the third power minus 1 plus 1. So I'm going to do this, negative 1, positive 1 cancel each other, cube root of x to the third power. So it's going to be, these two cancel each other, so it's going to be x there. So as you see, we end up with same thing. So it's going to be, yes, right? They are inverse of each other, yes. Inverse of each other. All right, g is the inverse of f there. Okay, let me make sure it's recording here. I don't wanna waste my time. Let me check. Great, okay. So let's move on. So I want you guys have a try those as well, and then you can see what we got. Alright, there's your turn examples. I want you to have a try. But let me show you one. So you can do this. I want to show you this one as well. Okay, let me go this way. Let's calculate f of g of x first, right? Which means f of g of x, right? So I know what gx is, right? G function is over here. Let me put over here f 1/2 x minus 2. So I'm going to take this, go to f function, right? Take this, go to f function. So 2, let's go to f function. 1/2 x minus 2 plus 4. Let me calculate this. Distribute this, right? 2 times 1/2 is just gone, it's x. 2 times negative 2, negative 4 plus 4, so we end up with x over 1. So we are good. On the secondly, let's try the other version, g of f of x. So it should be what? G of fx, right? So fx is what? Fx was 2x plus 4. G 2x plus 4. So I'm going to take this, go to g function now. Let's see what we got. 1/2 and 2x plus 4 minus 2. So distribute this, right? 1/2 times 2x, those two cancel each other, it's just x. And 1/2 times 4 is just 2 and minus 2. These two cancel each other, we got x there as well. So since we got same thing, so yes, right? They are inverse of each other. Because I done this one, please you complete this one. Alright, this is yours. Alright, let's move on. So that's the easiest one basically. If we have ordered pairs, if we have a table, how do we find the inverse? Like all what you do, just replace them, just flip them. So f should be what? So like this one goes here, this one goes here. That's all what we do. So answer A should be what? F of inverse, that's how we show it. So it should be 1, negative 2. If we replace those ones, should be 0, negative 1. This one should be 1, 0, right? 1, 2 should be 2, 1, and last it should be 2 and 2 anyway. Now, all what we do is replace them. I don't even want to do B. I believe you got this one. Okay, let me do. So 3, 1 should be 1, 3. 0, 2 should be 2, 0. Okay? 2, 3 should be 3, 2. And lastly, 4, 0 should be 0, 4. Just replace them. That's all what you do. Just replace them. Alright. And we do same thing on the table of values. Okay, let me copy paste this. We do same thing over here. So on C, even if we have a table, we are all fine. So it's going to be this. 3 goes this way. Those numbers come here. Those numbers goes here. So it should be 3, 12, 7, 10, and 2. And those numbers goes here. So the first one, 2011, 2012, and 2013. That's all what we do. Just replace them. That's all. Okay. Again, I don't even want to do that. Make sure you try those everyone. Those are your 20 examples. One more time. That's the keyword. Switch. Alright, here we are. Replace them. So, last part of this lesson is inverse equation. Let's say we have an equation, we have a function. How do we find its inverse? So we're going to follow those steps, everyone. We're going to replace x and y first, and then solve for y, and then replace y with f of negative 1. So, let me show you one example. It's going to make much more sense, everyone. So let's say that first of all, determine whether or not each equation defines one-to-one function. If so, find the equation of inverse. If you graph this, you should, okay, let's go to Desmos first. X squared plus 2. X squared plus 2. Oh, that's what we got, right? So is this a one-to-one or not? So as you've seen, horizontal line will cross it twice, right? So that's why it won't be it won't be 1 to 1. So that's why, let me graph over here, this is not 1 to 1. So it's gonna have like, it doesn't have an inverse, no inverse there. Okay, folks? So first of all, to find the inverse, like first thing we should do is to check they all should be 1 to 1. Like this two is 1 to 1, you can graph and see it. But this one not 1 to 1, so it doesn't have an inverse. Right? It doesn't have an inverse. Let's have a look at this one first. How do we find inverse of this function? Like remember that tree rule earlier I mentioned over here. First, step 1, interchange, replace x and y. So f of x means y equals 2x plus 5, right? So step 1 was replace them. It's going to be x equals 2y plus 5. And second step was solve for y, get y alone there. So to get y alone here, so we should do what? Minus 5 minus 5, x minus 5 equals 2y, and lastly divided by 2. So we got what? Y equals x minus 5 over 2. And last step was, that's your inverse, you got y alone, change this with f of negative 1. So it's going to be f inverse of x equals to x minus 5 over 2. And we are done. That's all. First, y equals, that's my equation, that's my function. Solve for y, get y alone here. Whatever you got here, that's your inverse function. That's my inverse. And that's how we say it. That's how we say it. You put the negative exponent up there. On this one, again, first step was y equals x minus 2 to the third power. Yeah, that's how we start off. And first step was change, replace x and y. X equals y minus 2 to the third power. So step 2 was solve for y, get y alone here. To do so, I should get rid of this 3 first. That's why, let me cube root of both sides. Cube root of x both sides. These two will cancel each other. Cube root of x equals y minus 2. And lastly, if I do plus 2 plus 2, I should be fine. Y equals cube root of x plus 2. So that's my inverse. F of negative 1x cube root of x plus 2. So that's my inverse. Just easily follow the steps and you will see. And then make sure everyone you stop the video and try those. Thank you so much for listening to me. Have a good one.